Hi, this is Venkatesh Prabhu. I'll be discussing about recycling bio. The purpose of recycling bioreactor is to optimize the maximum conversion of a reactor when the residence time is going to be less. In Chemostat, if the residence time is going to be less, the time taken for the conversion of reactor is going to be less. In that case, the effluent is going to be having unconverted substrate. In order to utilize the maximum amount of substrate, we need to go for recycling. This recycling is going to be done based on the additional some concentrated biomass along with the feed. So let us have I will derive the model for the recycling reactor. We must start with recycle. The recycle, when most of the people are getting confused with recycle process, but the recycling is also very easy. And to see the diagram is the reactor in which the normal field is going to be fluoride is here with the initial concentration of biomass is H0, the substrate as S0, and its effluent concentration is going to be here plus alpha. The X1 is the concentration. This has to be concentrated using the centrifuge. The biomass is coming out from the concentrated solution to export. And the part of the field biomass which is concentrated along with fluoride is going to be recycled back into the system. So this is the yes. So fluoride into the system is going to be alpha F. F is the initial field of fluoride, alpha F is the another fraction of fluoride from F. And the field which is going to have C into the X1 concentration. So this has to be calculated. The volume which is maintained by the reactor is V. So for this, we need to calculate the concentration of biomass which is coming out of the system as the X1. What is the model for X1? What is the model for S1? We need to calculate. So let us go and do that. So first, biomass balance. Biomass balance is a general balance equation is input plus formation is equal to output plus accumulation plus disappearance. So biomass is a formation process. In the formation process is there, some disappearance part is going to be negative. So input equal to formation, input plus formation is equal to output plus accumulation. So input is your x naught plus alpha f, the concentrated balance is Cx, then its formation is going to be mu x1, the volume V is equal to output is same thing f x1 plus alpha f x1 plus accumulation is V into dx1 by dt. So this is a general equation. We will take it as equation 1 and this as equation 2. So when we are rearranging this, accumulation V into dx1 by dt is equal to fx0 plus alpha f cx plus mu x1 into v minus f x1 plus minus again minus f, that is minus alpha f x1. This on further simplification, dividing by v on both sides, we have dx1 by dt is equal to dx0 plus alpha t cx plus mu x1 minus fx1 minus alpha fx1. So fx1 is also dx1 since it is divided by d. The reason is f by v is equal to b. So this is the point. Under steady state condition, under steady state condition, dx1 by dt is equal to 0 and the inoculum concentration is not tends to very less. So this is also going to be 0. So we could able to write as the equation as mu x1 is equal to dx1 plus alpha dx1 minus alpha d into c x1. This is also x1. So c x1. So I'm simplifying this. Let's start. Mu x1 is equal to x1 as b into 1 plus alpha minus alpha c. So x1 is going to be common on both sides. You could have also remove this. Then mu is equal to b of 1 plus alpha minus alpha c. So in a chemostat, without recycling, d mu is equal to d, whereas in say chemostat with a recycling, mu is not equal to d, mu is not equal to d, mu is equal to d of 1 plus alpha minus alpha c. So when you substitute alpha equal to 0, automatically you will also get it mu is equal to d. Now let us try the mass balance for the biomass. Sorry, mass balance for the substrate balance. Substrate balance. The same thing. Input plus formation is equal to output plus accumulation plus disappearance. Formation is a reducing process. It is not a formation process. So we could also write formation as 0. So input is equal to output plus accumulation plus disappearance. So we can able to write the mass balance for the substrate as F S naught plus alpha F S or S1. So we consider it as S itself. Fs is equal to 1 plus alpha F S plus E into ds by dt plus E into ds by dt. One term is for accumulation, the another term is for uh, disappearance. So further accumulation, we replace the disappearance term as disappearance term ds by dt is equal to E of 1 by y x by s of mu x mu x1. So when you are making the equation as v into ds by dt is equal to f s naught plus alpha f s minus of 1 plus alpha f s minus 1 by y x by s v x 1. So further divided by v on both sides, ds by dt is equal to ds naught plus alpha ds minus of 1 plus alpha ds minus 1 by yx by s mu x. So under steady state condition, ds by dt is equal to 0. Here we could not able to cancel out the cs naught because s naught is going to be very high when compared with the other one. So we should not remove this. So for the further equation, we are simplifying this one alpha d into s, alpha d into s is getting cancelled. Then we could able to write d of s naught minus s is equal to this term when it comes to the right hand side, that is 1 by yx by s into x1. So this is the final equation for the substrate balance. So d of s naught minus s is equal to 1 by y x by s of mu into x1. When you write for x1, x1 is equal to yx by s. So d is not minus s all divided by mu. So this is the biomass balance equation for a recycled system. Here we know that mu is equal to d of 1 plus alpha minus alpha c. And substituting these here, you'll be getting x1 is equal to yx by s, d and d will get so I'll write in most d of s naught minus s whole divided by d of 1 plus alpha minus alpha c. So d and d will get cancelled. The final equation is the x1 is equal to what is the equation? Y x by s of s naught minus s whole divided by 1 plus alpha minus alpha c. This is the mass balance equation for the biomass. So, if you know the biomass, that is specific growth rate, mu is equal to mu max, monad equation, yes, whole divided by As plus S. That means on finding the substrate, yes, we are rearranging this equation. S is equal to mu Ks whole. This is going to be rearrange this equation. Ks plus S is equal to minus S. Finding substitution using this will be mu Ks whole divided by minus mu. Now mu is equal to here 1 plus alpha plus c into Ks whole divided by minus of here 1 plus alpha plus c. Hence, x1 is equal to minus 1 plus alpha plus c of s naught minus of this whole here 1 plus alpha c into whole divided by minus here 1 plus alpha minus alpha c. So this is the final equation for the biomass concentration. I'll write it down. This next one is equal to variance plus divided plus alpha c plus minus b of 1 plus alpha c whole dx plus alpha minus alpha c. Thank you.